Let me extend India. Of Electronics at IIT Roorkee. It is our pleasure to welcome you all to this event. We look forward to commend it's our honor to light the lamp as the beginning of the event. Thank you, Kamal, Dean of Speech. May
immigrant at this settlement of Kamal continue to educate Dr. Amit Sharma lecture.
I'd like to request
यूएसबी वाला ना हाँ यूएसबी ऑडियो ठीक है लैटिन
Hello. Hello. Hi. This is I'm Pankaj Kamal, and
I would
elder
like
son of.
I would like to request you, sir, to please speak a few words.
Okay.
You're not
Hello.
audible, sir.
Yeah, the audio is. Can you
Yeah.
hear me now?
Yes, sir, you're audible.
Okay. Hello. I'm Pankaj Kamal. I'm the elder son of Professor Aditya Kamal, or AK Kamal. On behalf of my mother Saroj Kamal, my brother Arvind, and sister Amita, we are grateful to the IIT Roorkee continuing to honor my father with this lecture series. So thank you, Professor Pathak. We welcome Professor Anand Ramamurthy for this series. A little bit about my father. Of course, he dedicated his life to furthering advanced learning in science and technology. And his award-winning achievement was really the establishment of the Department of Electronics and Communication Engineering at IIT Roorkee, and at that time, of course, University of Roorkee. So thank you very much, and please continue the program with our best wishes.
Thank you. Thank you, sir, for sharing your memories, and we look forward to you and your family for joining us in the submissions of the lectures. Now, I would like to invite Professor A.K. Sharma, Dean of Faculty Affairs, IIT Roorkee, to address the gathering. Please.
All the colleagues. It's a great pleasure to be here and welcoming Professor Anand Ramurthy ji for this particular A.K. Kamal lecture. It's the 5th edition of Professor A.K. Kamal Memorial. And it's really good that we have constituted this as he was the founder head of the Electronics and Communication Engineering. It's not working. So online meeting. Okay. So good morning to all. I repeat this since it's an online meeting. So good morning to all students and faculty colleagues. I am very happy to be here, and I welcome Professor Anand Ramurthy ji from Micron, India, to be the speaker here. And we thank you for accepting our offer and head of the department's offer to speak at this particular memorial lecture. This is 5th edition of Professor A.K. Kamal lecture series. And I suppose as a founder head, this is a very good initiative which has been taken. I thank you all the audience. I think students have come, although end-term exams are going on. Still there is a lot of crowd here. So thank you all. And thank you. I wish you all the best. Thank you. And I would, without any delay, we will request Professor Anand Ramurthy to deliver his lecture. Thank you.
Moving ahead with the program, now we will have the lecture session by Professor Anand Ramurthy. Before starting the session, I would kindly request Professor Sanjeev Manhas to introduce the speaker.
You can keep it very short. Huh? Don't bother to read the whole thing. So very warm welcome and good morning to all. It is indeed my pleasure to introduce to you Anand Ramurthy, who is well-rounded technology executive with over 2 decades of global experience building high-performance teams, introducing flashy products, scripting executable strategies, driving nonlinear business growth, and leading organization transformation. Anand is the founding managing director at Micron India and is responsible for engineering, R&D, operations, and sales. As you know, the Micron is a $30 billion global leader in semiconductor memory and storage chips. Under Anand's leadership, Micron has grown over to 4,000 professionals in 5 years in India, and its fastest headcount and competency RAM in Indian industry. The India-based engineering team have impacted more than $25 billion of products to Micron, which includes in mobile, automotive, data center, IoT, and embedded systems. Micron has also recently decided to set up India's first semiconductor manufacturing operation in Gujarat, which is really a new era in the country. And it's our march towards self-sufficiency, and we're really very happy to do that. He also sits on the board of several companies, including both Hexagon Software, and is part of NASCOM, MCAM, and other executive boards. Anand is alum of Harvard University. He obtained his undergraduate degree from IIT Roorkee, and which was followed by MS and MBA degrees from US University. So it's really an honor to welcome you and hear to your thoughts. Thank you.
Thank you, sir. Now I will take the opportunity to welcome Professor Anand Ramamurthy for the distinguished lecture. I'll hand over.
You can next time. ये back. Just Can I avoid this or? You can. You can. Huh? You can use this one. Yeah, that's best for that. Yeah. Just press the audio. Yeah. You can take it this one or place it over there. All good? Yeah. Okay, wonderful. And how do I get the PowerPoint started? Yeah. We'll share the slides. You can share the slides. And you can move around if you would like. Yeah, I prefer that. Hey, a very good morning to all of you. It's an absolute privilege to be here this morning. And I had actually arrived in Roorkee over the weekend, and I joined the Foundation Day yesterday. And then Professor Pathak said, since you're in the campus, you absolutely have to come and give a lecture. And I couldn't say no to the professor because that's by habit, right? You never say no to your faculty and senior faculty. So again, it's wonderful to be in the campus. It's home for me. And every time I come home, I feel emotional, nostalgic, and also feel obligated that I should, in some small form or shape, give back to the school and the college that has served me so well. This morning, privileged to be part of this lecture series. Professor Kamal, who was the founding head of the department for this department. So I feel very privileged to be part of that circuit. This morning, I thought there are so many things to talk about, but these days, everyone seems to be talking about AI. So I will not buck the trend. I'll also talk about AI. But one thing I will do differently is talk about AI in the context of silicon systems, and Micron. Of course, I have to plug for Micron. I represent Micron. But overall, this is going to be a little bit of a commentary. It cannot be a detailed technical note. But if you have interest in a specific area, we can obviously make sure that you get more information going forward. Okay, with that, I think I have a video. Let's see if that one plays well. Videos are always tricky to play. We'll find out how this works. Yes.
Our world, our experience, is being transformed by data. Artificial intelligence, machine learning, predictive analytics, neural networks. These aren't technologies of tomorrow. They're here today, analyzing, modeling, predicting, and discovering, uncovering deeper, more human insights, and enriching life's experiences. And it's all made possible with Micron. Our memory and storage is at the foundation of this data transformation, storing the data generated by practically every type of smart device and high-speed computer on the planet, and pushing processing to the next level.
The video from and we can have the audio from here, and they will just play the audio. I'll just explain it.
Our world, our experience. Our world, our experience is being transformed by data. Artificial intelligence, machine learning, predictive analytics, neural networks. These aren't technologies of tomorrow. They're here today, analyzing, modeling, predicting, and discovering, uncovering deeper, more human insights, and enriching life's experiences. And it's all made possible with Micron. Our memory and storage is at the foundation of this data transformation, storing the data generated by practically every type of smart device and high-speed computer on the planet, and processing to the next level, 2.5 quintillion bytes per day, every day, and growing exponentially. An infinite torrent of data. We're turning information into insight and activating data to reach higher realms of productivity and innovation. We are Micron. And we are transforming how the world uses information to enrich life.
We are Micron. And we are transforming how the world uses information to enrich life.
Thank you. That was a good example of Indian jugaad, right? So we'll go back to so again, glad to be here. Most of you in the classroom, with the exception of faculty, probably were born after 2000 or somewhere closer to that timeline. So you may have missed out on some of these very big technology shifts that you may have heard about, but not lived through. It started with personal computers, personal computing. The 80s and 90s saw the whole Windows and Intel kind of coming to shape. PC as a productivity tool was an important inflection point in how we actually interact with machines. The first foray into interacting with machines, using them to automate, make things faster, better productivity. Then, of course, we had the smartphone revolution. I wish it had not happened some days when I get completely besotted with all the content that is sitting on a smart form factor. Smartphone was essentially the same compute power in a slightly smaller form factor. But what we are now witnessing in the last, I would say, 4 or 5 years, and ChatGPT kind of accelerated the whole trend, we are seeing probably the first real marriage between technology, data, and human cognizant behavior, right? They are calling it the era of human intelligence beginning to be mimicked in and by machines. It's a slow process. There's a lot of terms being coined. There's the term called narrow intelligence, and there's something called general intelligence, and then a super intelligence. But what it basically means is, in spite of everything that we have done in technology, in electronics, the human brain continues to be the very difficult, complex frontier to conquer. Because machines have done things that we human minds and brains can't do very well. Fast computation. You want to multiply a 13-digit number with a 13-digit number, the calculator or the computer does it so fast, we can't. But the power of reasoning that we possess is something the machines have often failed and still are failing to comprehend, because the human reasoning is abstract, is complicated, is very, very nuanced. So what we're trying to do in the broad area of artificial intelligence is to use the power of compute and the power of training models to ensure that we can start mimicking the human brain in more ways than one. Now, that process, based on who you talk to, is a long drawn process. Some people believe we'll have some level of general intelligence capabilities by 2030, and probably some very advanced intelligence where it is much faster, better, and more reasoned than human brain by 2040, 2050 timeframe. But in spite of all these timelines, one thing that cannot be debated is the era of AI has arrived. And there is a very interesting saying that human brain tends to be a little more non-linear, more linear in thinking. And so very often we overestimate the impact of technology in the short term and underestimate its impact in the long term. So there might be a little bit of too much of AI in the short term because we feel it's going to be a lot of magic. That will kind of get calibrated over time. But one thing is for sure, that we are, all of us together, are witnessing what is clearly an era where human intelligence will be mimicked, leading to a lot of positives and some areas of concern that I'll briefly talk about during my talk. It's a big market. You see, any technology trend has to be backed with a strong business proposition. It doesn't have to be always in that order. You can have a value proposition and then monetize it, or have a monetizing model and create technologies to kind of further it. These are forecasts and numbers. They may or may not pan out. What it tells you is by 2027, that is a few years down the line, this whole AI market, and I'm ignoring all the traditional optimization and analytics and the things that are already happening. This is true AI as we understand and comprehend, would be almost close to $1 trillion. To give you a sense of why that number is amazing, I represent the semiconductor industry. This industry is almost 5 decades old, and the total semiconductor addressable market today is almost 500 billion, 500, 600 billion, and it will be close to $1 trillion by the end of the decade. The industry, which is so foundational, so fundamental, has taken over 5 decades to go from nothing to getting closer to $1 trillion of market size. And here we are seeing in less than 5 to 7 years, the forecast at least is that we will be closer to a 990 billion or $1 trillion before the end of the decade. And then what you see are a whole set of different AI related, it's not going to be, AI is not a monolith. It is a lot of layers because there is a foundational part to AI, which is the foundational AI enablers. These are the semiconductor players, the likes of NVIDIA, AMD, Micron. We believe we are truly enabling, and I'll tell you a little more about how we are enabling AI. That is the AI enabler part, building the chips, the GPU computational power, the memory bandwidth, and everything else around it to ensure that AI computation and training can happen. That's one part of it. There is an AI IT related, I don't know how many of you have started using AI tools like Copilot and others in your day-to-day functions, but there is a lot of IT tools coming your way, which will help you with productivity and trying to summarize presentations, do all these little things that were much more time consuming and very hard to do early on. So as you can see, all of these segments within the AI monolith are growing at different CAGR, which is growth rates are different. But the one which is growing the fastest is the models. And these are the large language models like that you all are aware of. And also there is the talk of more and more small models, tiny models, models on the edge. But essentially these are the foundational data sets that we are creating, which when prompted can give you a lot of human-like responses, which is what we're trying to create. So the market is not just evolving, it is forecasted to be commercially very viable. And trust me, as someone who's been in corporate for a couple of decades now, this is important because having a technology for the heck of it is never really helpful. If you don't have a monetization model or a business model attached to it, it dies a death. So amazing to see that there is some huge numbers behind this big AI trend. I briefly mentioned about some of the applications for generative AI, and these are examples you're all very familiar with. It could be in a customer service contact center. You already are exposed to a lot of chatbots. Nowadays, very hard to get hold of a human being to solve a problem. So you have bots who essentially are reading out recommendations from a known set of data and decisions that have already been validated and inferred. Being used in sales and marketing, software development, a lot of low-lying code development can happen. My college-going son tells me that his Python coding skills over time will become redundant because he has there are so many different ways of actually reducing the software development and coding process itself. Of course, back office. Now, there are two ways of looking at it. Clearly, a lot of automation is coming our way. Clearly, things are getting faster, better, efficient, productive. There is also, as many of you are students aspiring to get jobs, I want to highlight, don't be, my 2 cents advice, don't be too paranoid. This is an excellent opportunity to skill, reskill, relearn, and get ready for a market. If you look at our human history, we've had several disruptions come our way. I talked about PCs and smartphones, even much before wheels and fire, and every disruption that came, there is a great ability of humans to adapt and still stay relevant. So my opinion is we'll all be very relevant as long as we have some sense of reskilling, retooling, and being able to go and skill ourselves to face this new world where there'll be enhanced, exciting automation happening across all the different pieces of tools and processes that we face in a daily life. And this is a very interesting way of looking at the same thing. What it shows is base by service, what kind of increased automation. And this is the eye chart, you may not be able to see all of it, but what it actually shows is what is the level of automation today and what does it become once we have a lot more of AI enhancements coming. And as you can see, all these different processes, some more, some less, but all of them are supposed to go through enhanced layer of automation and productivity over the next many years by incorporating more and more of AI processes and tools. Now, this is interesting. I'm just going to take a couple of examples. I've been telling you that AI is truly transforming verticals. I want to pick a couple of them. How many of you know about this company called Moderna? Have you ever heard of them or heard of them or heard about them? Give me a raise of hands. I won't judge you. It's okay if you don't know them. Okay. So I'll digress a little bit because it's very important. When COVID hit, if you recall a few years back, and you know, the whole world was racing to go and find vaccines, including India. And there was this very small company in Boston called Moderna, which is actually a very small company. They were making vaccines. They were using a very interesting technology called messenger RNA, which is a very different way of attaching yourself to the human body. And they actually did not have a COVID vaccine per se. But what they did was the entire Moderna operations was AI enabled. From their manufacturing to their R&D, they had a platform approach to how they built vaccines. They were not building vaccines for a specific disease. They had a foundational platform which they could go and customize based on the disease vectors and how to go and manage a particular disease. And here was a case when the entire, the genetic footprint of this virus was I think probably Jan 2020 when they got to have the complete mapping of the genetic genealogy of this one. And within 12 months, you actually have a very highly, and vaccines development is a very long drawn process, taking up to 3 to 4 years typically because of the human testing that goes behind it. Here is a case of a vertical of a business that by incorporating elements of AI in almost all their processes, starting from R&D, to workforce management, to manufacturing, was able to actually help mankind build a very superior vaccine in less than 12 months and be so effective. Of course, we use a different vaccine here in India, but Moderna was one of the prominent, along with Pfizer, one of the dominant vaccines used in USA and many other parts of the world. So we already have amazing examples of how adoption of AI is truly impacting business. The other one I want to tell you about is closer to our business here at Micron. It's in the area of smart manufacturing. What I mean is semiconductor manufacturing is complex. Many of you are familiar, but for some of you, at a very, very high level, it is essentially a little bit of what we call the front end and the back end, right? The front end is where we actually, the wafer processes are taken care of. The back end is where the wafers are sliced, diced, and packaged, tested, and shipped. And the numerous processes, very complex process flows, and the yields have to be very high in semiconductor. Because it's not just about making silicon effective and the circuits working. You have to make sure that you're yielding at very high levels for economic viability. To give you an idea, if the silicon is not yielding at 99.5+% at high volume manufacturing, then it's probably not a great business model, right? So what it does is there are so many process steps, from etching, deposition, litho. When you look at the entire workflow for a traditional wafer that runs through the semiconductor process, there are so many places where you can actually find out problems, root cause. It could be the visual inspection of the reticles. It could be so many different, lot of video analytics opportunities, a lot of opportunities to look at testing time and see, because anytime you reduce the test time, it has a significant impact on cost structures, right? So we have in India, for example, around 400 smart manufacturing engineers. We have the ability to actually, apart from doing all these smart manufacturing functions, we have what is called a remote operations center. So all the fabs that we have in Singapore, Taiwan, Japan, we can actually possibly remotely look at them, look at areas of predictive maintenance. Because once the equipment goes through a downtime, it has significant impact on cost and quality. And by remotely monitoring these operations, sitting not next to the fab, but many thousands of miles away from the fab, you can actually look at almost every single process step and provide interventions in a very timely, predictive way. So there are many more aspects to smart manufacturing. We're looking at more, as I said, more and more of visual inspection. We are trying to do what is referred to as shift left. Every time you shift left in a process, you're trying to make it statistically more compelling, more compliant, and much more effective. And every day, our data science engineers are finding newer and newer ways to improve more and more of this efficiency. And every time we do that, we are saving money, we are saving cost, and we're also bringing in an element of sustainability, because you're reducing test time, you're reducing utilities, all the power that is being used in a typical manufacturing flow. So I can keep on giving you many such examples. Many of you are obviously very aware of AI as it applies to Netflix. Your recommendation engine plays such a wonderful job of telling you exactly what you need to watch. And that's the simplest form of how our world today is largely conditioned by these machines making great predictions about what we aspire, what we need, or what we like to see. So the bigger drift of saying all this is not a single business word, not directly, indirectly impacted by applications of AI. And every example is compelling, sustainable, and meaningful and material. I'll shift gears now. So I was giving you a little bit of AI, business verticals, market size, addressable TAM. I'll start talking a little more about how AI starts addressing silicon systems and silicon design and silicon flows. Now, one of the biggest challenges, I have been in this business for over 2 decades. One thing that frustrates all of us is the typical time it takes in silicon design from the time we have an architecture or what we call an MRD or a product requirement documentation or a market definition document. From that time to actually get a truly working silicon takes anywhere, any guesses? How long does it take? It's a rule of thumb, it can vary, but just give me some guesses here. How long does it take from the day I start thinking about a silicon design to the time I actually get a piece of silicon that is working and functional? 6 months to 1 year. Who said 2.5? Yes, almost 2.5 years, right? And of course, it can vary depending on what kind of, is it a digital chip, analog chip, kind of logic blocks you have. But the typical rule of thumb is by the time it takes, and that's a very long time. In about 2 years, markets can change, needs can change. So one of the biggest challenges we have, which is why AI is a great possibility for us, is the unacceptable time it takes from design, architectural specifications to getting a useful single piece of silicon. And that waterfall method of how we do things very linearly. And so when you do things linearly, you take one step at a time, and you have, you design, then you transfer it to a fab, silicon comes out, you test, and then you get it ready for high volume manufacturing. Of course, with or without AI, one way of trying to shrink that design time is to start simulating a lot of the hardware and the software that's needed to run on that hardware earlier in the game, which is what we call a shift left emulation/simulation, right? So what it does is, even though I don't have the hardware, I try to emulate or simulate what the hardware might look like and provide a hardware-like environment so that I can actually test out many of the things early on and actually wait for silicon. Different small techniques that we have been using in the last couple of decades to essentially shrink the time it takes. But I think these interventions are effective, but have not really led to any material reduction in the cycle time of silicon. So we now feel, and we are seeing these experiments getting carried out at my R&D centers in Hyderabad and Bangalore, we now truly believe that by using what we call a lot of AI agents meaning every single flow that you have, a typical flow, you have design specifications where you're figuring out what your design is intended to do. You have the architectural framework in mind. Then you start deriving a functional design, the logic design, then you design the circuits, and then you do the physical layout of these, and then you verify them. We are looking at almost attaching an AI agent at every flow. Let me give you an example. A significant part of my R&D design in Hyderabad has a lot of what is called layout. Layout or floor planning, physical design, all different manifestations. We're just trying to figure out how these small cells need to be laid out in the final circuit. And the process is manually intensive. It needs some level of electrical circuit knowledge, but not too much. The perfect place to automate, because we have a lot of old historical data that we can go and piggyback on and figure out how we can do more efficient floor planning and layouts without having someone playing with polygons and doing this day in and day out. Same for verification, when we're verifying the functionality of a piece of silicon, both pre-silicon and post-silicon. So we are beginning to figure out all these different steps in the design flow where we have an agent that will essentially, with the human in the loop. So there is always human in the loop here, and there is a feedback loop here, right? We take, hey, listen, this is working well. We go ahead and just like your typical feedback loop in circuits, and ensure that that particular model is trained for how the agent can work on that particular flow. Early days, we are beginning to see some productivity enhancements in areas where human intervention can be done away with. I gave you the examples of layout. Some part of verification. Testing is another area where we feel we can automate a lot. And I think this is going to gain ground. We're also finding not only are we reducing these design time, we're also improving the quality of circuits. Manual intervention can sometimes lead to problems, right? Because as human beings, we make mistakes and errors, and an automated tool with better training can be a little more efficient. So this solution is revolutionary in some ways very foundational, because if we do this really well across many functions, we are going to truly impact the performance, the quality, and the cycle time of silicon across all the different vertical segments that plays in. So this classic human in the loop, agent-based flow will clearly be the way how silicon is designed going forward, especially more and more complex silicon, because that's where we need the most help. Again, shifting gears a little bit, that's kind of the fundamental way of how we're going to change silicon flow using a little more of AI. I'll shift to Micron. Micron, for those of you who are not too familiar, we are a semiconductor company that make DRAM and flash storage chips. So it's very likely that you open up your laptop, your smartphone, the data center that you're pinging has a lot of Micron inside it. We don't have a campaign like Intel inside, but it's very safe to assume there's a lot of Micron inside many of the devices that you play with. And here is a snapshot of the portfolio that actually is driving this AI momentum. I won't go through all of them. I'm going to focus largely on one category called the high bandwidth memory, because that's probably the most impactful solution that is coming up in the area of AI. But just to give you an idea, there is obviously graphics, GDDR chips. We're talking about more and more low power DDR, because power is important. As we keep on needing more and more computational power, the biggest challenge we have is, hey, how much power these data centers suck? And how long can you keep on feeding them with so much power? So, so clearly we want to make sure that architecturally, we also have more and more of low power devices in the system. Then of course, a lot of different interfaces coming. There's a CXL interface. You're probably familiar with PCI and others, but it's a super portfolio that Micron possesses, which is fueling this AI revolution we're talking about. I'm going to spend some more time on high bandwidth memory. Before I get there, so the traditional architecture in an enterprise class so far would be, hey, I have a CPU. It's very CPU centric. It could be an Intel or an AMD processor. Then of course I have access to storage, SSD or HDD, and then I have access to DRAM, the DDR, so DDR4, DDR5 interface, right? And that architecture is actually getting challenged now. That's why if you are following the news, Intel is used to be a superpower, is going through a period of transition. And NVIDIA, which was more of a graphics player, has become the new benchmark for how enterprise class servers are designed. So what is actually happening now is you're seeing the reintroduction of GPU and GPU memory, which are going to play a very important part in driving a lot of these AI stuff. So a couple of pictures here, which are useful and relevant. The first one is we asked DALI, all love to have these fun with these agents and see what they come up with. We said, hey, listen, and I'm sure all of you have played with these toys in your life. Tell us about, give us an image of AI. This is an abstract painting of artificial intelligence. I have no idea what this means, but it tells you a little bit about how these engines are beginning to reason like many of us. The second chart kind of highlights, we talk about training these large language models. Of course, there is a great increase in the number of parameters that are being used. Just from ChatGPT 1 to ChatGPT 4, you can see that the number of parameters have gone an order of 5 or 6, from 100 odd million to over 1.76 trillion. And it's going to keep further improving as more and more of these LLMs start getting us closer and closer to human general intelligence or human super intelligence. It takes a lot of time to train them, be that be change from CPU centric, we're becoming very GPU centric. And when you become GPU centric, you want to make sure there is a different class of memory that the GPUs can quickly access for quick computation, quick decision making at lower powers. It takes a lot of months, it becomes a very important factor. So when you put this all together, it became very apparent to us that our traditional, because we make NAND chips and DRAM chips, it became very obvious and apparent to us at Micron that to fuel the next revolution in AI, we have to start thinking of a slightly more revolutionary way of designing memory, which is called the high bandwidth memory. At a very simplistic level, instead of having one single DRAM die, what we're doing in high bandwidth memory is stacking a lot of DRAM dies. When I say a lot, we have 8 layers, we have 12 layers, we're talking about possibly 16 layers. Just like NAND, we'll keep on scaling in the z-axis, and so there'll be more and more layers, hopefully. Instead of one DRAM, you have 8 DRAM. So obviously, you're improving your throughput, the flow of data between your memory and the GPU. So instead, because of Moore's law, there's obviously a lot of constraint on how much, how fast, how small, and how powerful. Get them up. Then we have a logic die layer in the memory. It's more of the computing part of memory, and this ensures, like for example, the picture I'm showing you here is called the HBM3E, which is our flagship high bandwidth memory product. This is the product that goes with most of the NVIDIA platforms that are being used in AI training today. The densities will keep getting better and better. It's 24 gig, bandwidth of up to 1.2 terabytes per second, and I/O speed of 9.6. Power is very, very efficient. In fact, we have the lowest power, both at a transaction level, at a performance level compared to our competition. And this is based on our flagship leading edge DRAM process node. And this is shipping as we speak. And so this is a wonderful, wonderful human ingenuity. We have what is called a through-silicon. DRAM dies are connected. I'll spare some of the technical details, not relevant. What is again very important to understand is this is a very interesting way, and I'll show you a picture. Hopefully it's coming in the next slide. Let's see. No, it's not coming, so I'll stick here. So what's actually happening is we have now figured out if you have a A100 or the, NVIDIA has this it will be surrounded by high bandwidth. In a traditional model, it would be a CPU with the DDR, but now we have a GPU, we have high bandwidth memory. In some cases, on the inference side, we may have some low power DDR, but essentially at a high level, the partitioning of logic and memory is going through a big change. What used to be a traditional model is getting repartitioned because the focus is on bandwidth, the focus is on keeping power low, and also the focus is also on cost. Over time, all these innovations will ensure that at a per GB, the semiconductor has a great track record through efficiency and improved yields, bringing costs down over time, essentially an extension of Moore's law. We hope to see that happen with HBM memory too. I'll talk later about it, but maybe I'll just put a plug here. What makes me very proud, such a compelling, amazing technology. Over 50% of the engineers and many of these are new college grads, like many of you. DRAM design is virtually non-existent in the country. If some of you are don't feel bad about it, because it's never properly taught, not because of any curriculum challenges. It's not really a traditional part of how we are taught. We took around 28 new college grads from IITs across the country. We trained them for 6 to 9 months with our folks in Japan. They come back and they help verify, test, do layouts, some part of design and some product engineering for the HBM3 chip. So very proud moment for the country and very proud moment for what each one of you can possibly do if you put your mind to it and work on extremely leading edge technology that is going to be very relevant for the next many, many years. So just a point of motivation for each one of you. Please, semiconductor has significant labor shortage. So if you put your mind to it, there are so many opportunities. You know, I talked about HBM from a traditional silicon standpoint. You can imagine as you start stacking all these DRAM dies, there are thermomechanical issues coming in. There are packaging issues coming in. You could be a mechanical engineer. You could be a material scientist. You could be a classic engineer. All of you have a role to play here. You could be a traditional process guy. There are so many challenges in getting this up and running and getting it to yield that all of you have an opportunity. So if this is not exciting you, go back and read about HBM3, and I'm sure you will find a lot to lean on and make sense of. I talked about low, also an interesting action happening. The low power DRAM is largely in edge devices. You see, data centers power is critical, but it is not going to be the long pole in the tent, right? Because you don't have the power budgets that a typical smartphone has. So anytime you're talking about a laptop or a smartphone, clearly you cannot have a very large battery. You have real estate constraints, you have power constraints, you have thermomechanical issues, you have heating issues. So clearly we are seeing a significant amount of innovation happening in low power DRAM. Essentially traditional DDR products that we are now ensuring through changes in how they are designed, leading to low power. Again, our Micron India is a significant center of excellence for low power DRAM. We are going to build a lot more for automotive and mobile applications. Another big trend happening. So if you open up more of your recent laptops, instead of traditional DDR memory, you might start seeing a lot more of LP, low power DRAM, actually showing up in these platforms. This is a wonderful product. I'm interestingly very proud of. So Samsung is competition to Micron. We compete with Samsung because they also make memory, DRAM and flash. And here's a great example of the Samsung president talking about Micron memory in their flagship S24 phone. Have you guys heard about the S24? Does anyone own one or know of it? I guess you're all Apple guys or Android guys. What is it like? How many Android folks here and how many? Yeah. Engineering colleges are still stuck in Android, huh? They're like the good thing. My son is also stuck with Android, and we talk about it. But hey, great example. We are beginning to see proliferation of AI smartphones, AI PCs. What it does essentially is it will obviously have more computational needs, more memory needs. That's density. You know, we're talking of 12 GB or maybe up to 16 and higher GB coming up in flagship smartphones. But this is again a great example of how you enable AI in edge devices with a significant focus on power while keeping the performance alive. And so Micron collaborating with Samsung to unlock the era of mobile AI experiences. You guys know him? He's very popular. You better know him now. So this is Jensen Huang, the CEO, founder, co-founder of NVIDIA. This is a picture from the recent GTC event, 2024 keynote address. And what you're seeing there is HBM memory that is sitting around LP memory and HBM memory. His GPU occupies more silicon space in a typical package. That tells you the importance of how much memory is such a key enabler for the AI revolution. And that's the board that he showed at the GTC platform. And you see the amount of memory. It doesn't matter Micron memory or someone else's memory. The fact is that is the amount of memory needed to ensure these trillions of parameter transactions we're talking about are happening seamlessly in next generation AI systems. So truly, we're seeing that HBM, low power DDR are truly enabling. This is the NVIDIA Blackwell system, the recently launched platform for the next generation AI. I will finish with a little bit of plug for Micron India. I told you a little bit of a story. We are a relatively young site, unlike some of our peers like Intel and Qualcomm and AMD. We started in 2019 in real. I was the first country head for Micron. We have development sites in Bangalore and Hyderabad. We have a factory coming up in Gujarat. It's a back-end assembly, test, and manufacturing site, the first by any semiconductor major as part of the Prime Minister's policy of building more in India, for India, and for the world. Our development sites do both NAND and traditional engineering execution. We also have teams doing research in many areas. For example, CXL, the new interface, the Compute Express Link. I talked about HBM3, a lot of leading projects. We do a lot of both front end and 4,000 plus members. And in a very short time, very proud, we have over 1,000 patents, disclosures, and inventions for a site that is still very, very young. That is a reflection of the kind of work we get to do and the kind of work that Micron is doing. Put them all together, truly flagship development sites for any engineer to come in and work at. All I had. So I would just like to briefly summarize so the takeaways are not lost out. The AI revolution has arrived. There is no need to debate about will it or won't it. I'll also just to the end provide a quick commentary of how AI relates to India, because we're all living in India. I was in a session last week. There was a discussion about its own large language models, or should we just let the guys in Silicon Valley build these models and we just kind of calibrate it for our applications? Now, everyone has their own view. I have my own personal view. I think we should do both. I think we should do both because it's not an either or equation. I think we should also build our own model, keeping in view our cultural biases, our linguistic diversity. Of course, the data is still not big enough, but we'll eventually get there. The reason I say that is if you look at any of India's success on the digital side, you look at Aadhaar. Aadhaar was a foundational innovation that is leading to so many different applications coming out of it. And sometimes you just should not be working at an application level. You should start looking at foundational intervention and innovation. So my personal view is, I know there are companies like Ola, Kritrim, they're building their own little LLMs. I know IIT Bombay and others are also building their what's called the Bharat GPT. So a lot of these things are happening. So that's one part of it. I think India is well poised because of the scale and the talent that we have in the country. Many of them are in the room here today. We can, should, and be a very active part of getting involved in the entire AI stack. They are getting geared to play in that AI revolution. My personal view is we should continue to be very cognizant of the challenges that AI will eventually have, because we're going to have a lot of fraud and poor decision making representing humans happening, which can lead to a lot of disruption in how we build and work in societies. But I think I have a lot of trust in our human ingenuity to get the right frameworks in place. All the countries are working on AI advisory policies to make sure that we have good guardrails and controls in place. My personal sense is with innovation on its course, let's not come in the way of making things happen. And last but not the least, clearly don't look at AI as a buzzword. Some of you may be cynical, saying, oh, just talk about AI these days. Truly understand what it's trying to do, because the concept of AI is not new. 20 years back, when I started my career, I was working on the first neural network-based voice recognition systems. We've always had some representation of AI flowing into our world and our life, and it has actually just gotten evolved with the low cost of computing coming our way and the depth of computing pervasiveness that has come over the last couple of decades. So it's a wonderful inflection point. You're all in the middle of that inflection point. And just like the internet era or the smartphone era, if you don't participate in this era in some form or shape, it will be a little bit of a miss out. So with that, I wish you all well in your life and career. Dr. Pathak, again, thank you for giving me this chance to engage with the class. And Micron will continue to be very supportive of things at IIT Roorkee. And good luck with the lecture series, and thank you for your time. Should I walk down? Awesome.
Thank you, Professor Anand Ramamurthy, for sharing the insight into the opportunities that await. I'm certain your talk has been instrumental for all of us in advancing our understanding in latest breakthroughs in AI hardware, advanced memory technologies, as well as solid-state drives. I would like to invite Professor N.P. Pathak, Head, Department of Electronics and Communication Engineering, to present a shawl and a memento as a token of appreciation to Professor Anand Ramamurthy and propose the vote of thanks. Thank you, sir. Please take this. This lecture series provides us with an opportunity to remember and thank Professor A.K. Kamal for his valuable contribution to our institute as well as to the field of science. Looking forward to the next lecture in the series in 2025. With this, we have come to the end of today's event. Thank you everyone for being a wonderful audience, and relish the high tea that's arranged outside the auditorium, and have a great time. Thank you all.
Thank you.